Hello students, welcome to the 5th episode of our video example series for Circuits 1 here at NDSU. In this video we are going to focus on voltage division and how we can use it as a tool to do some quick calculations in a circuit such as this. We have a voltage source of 75 volts, a 10 ohm resistor, in parallel with a 20 ohm resistor in series with a 10 ohm resistor. Okay, let's say we're going to look for the voltage Vx across that 10 ohm resistor. That's our goal. What does voltage division tell us? It tells us that the voltage Vx is going to be equal to the voltage supplied to this part of the circuit, let's call it Vs, multiplied by the ratio of the resistance that Vx is across over the equivalent resistance seen by the voltage supplied. In this circuit, the voltage supplied is pretty clear. It's 75 volts. We have 75 volts from right here to ground. Now, we could have other components back here, maybe some resistors, maybe some capacitors. We'll get to that later. However, for the sake of this example, if we know the voltage at this node, this 75 volts, and we're only going to consider what is to the right of it or below it, across it in this case, that 75 volts is across the 10 ohm resistor as well, then voltage division will allow us to quickly solve for Vx. Let's do that. Okay, Vx is going to be equal to the 75 volts that's being supplied to our circuit times the ratio of the resistance that we're measuring across, Vx is across the 10 ohm resistor in this case, over the equivalent resistance that this circuit is going to see. This circuit sees 20 ohms plus 10 ohms. 20 ohms in parallel with 10. It's going to give us 75 times 1/3. It's going to give us 25 volts. There is 25 volts across V1. Awesome. Like I said before, this is a tool. We use voltage division to do a quick calculation. It's not often that you're going to get a circuit like this that's so easy that the voltage source is going to be the voltage that we actually use within our circuit. However, what we need to note here is if we have the voltage at a certain node, we can use that as the voltage supplied to find the voltage across any resistor that we want, as long as we're considering all of the equivalent resistance that's being seen by the voltage supplied. Thanks for watching.